I really tried to avoid philosophy, I really did. We have no idea what causation actually is. In fact, we have very little knowledge about anything really. Let me explain what I mean by that, how I came to that conclusion, and why it's actually so frustrating. Okay, for context about me, I lean towards the field of applied mathematics. I do anything so far as it is useful. I'm not scared of philosophy, but I only interact with philosophy so far as it is actually applicable to me or to you in practical day-to-day life. The point of this video is to explain how the question of what causation is actually very relevant, and then my sort of analysis as to what causation is versus isn't. I should really stress, I'm not a philosopher. I don't read books on philosophy. I'm literally just someone interacting with the real system. I think about things, I come to conclusions. Perhaps there's terms for all the things that I'm going to mention in this video. I'm not going to know what those terminologies mean. I haven't read anything about this. I'm literally just thinking from first principles. Okay, I'm not gonna waste any more time. Let's just get straight into it. So you've heard before that correlation is not the same as causation. So something like in statistics, for example, if you're doing analysis on a set, you have like XY graph and there's some kind of clear correlative relationship, but that doesn't necessitate that there is causation. And that makes sense at first. In fact, there's a whole website, I don't know, I forgot what it's called, but my maths teacher showed me this once. There's a whole website essentially dedicated to random correlations between things that are like completely unrelated, like cheese consumption versus pianos falling on you, like completely random, unrelated stuff. But they have correlations. From a basic logical premise, that makes sense, right? If causation always implies correlation, right? For two things, if my punching you in the face like directly causes your lip to burst open and bleed, for example, then every time I do that thing, that should happen. So causation implies correlation, but that doesn't necessitate that correlation implies causation. That's like a simple mathematical principle, right? If A implies B, that means that whenever A happens, B must happen. But it doesn't mean that only A implies B. So like A could imply B, for example, but C could also imply B. So for those of you who do like formal logical mathematics, it's like the difference between an implication and an if and only if statement. So an if and only if would mean that A implies B only if B implies A, versus like A implies B, but C also implies B. So like my punching you in the face could cause your lip to burst open, but also if you tripped and fell on a desk or something, the same result could happen, essentially. And this kind of concept comes up all the time in practical day-to-day sense of like, let's say you're doing science, for example. So science deals with supposedly causative links. You're looking at, let's say, there's a button and there's a switch. There's a switch, and when I press the switch, then the light bulb switches on. What would you say in that scenario? Would you say that my pressing of the button causes the light bulb to switch on? Or would you say that there is a correlative link between my pressing of the button and the light bulb switching on? In a normal statistical sense, you would call that, or in science, for example, you would call that a causative link, because literally every time I press the button, the light bulb switches on. But what actually makes it a causative link versus a correlative link? Science only deals with the measurable and the observable. So what I'm actually measuring is that I've collected a bunch of data, i.e. I've pressed this switch 1,000 times, and for the 1,000 times that I pressed the switch, the light bulb just so happened to turn on, right? So that in its very nature is a correlative link. I'm saying every time I do this thing, then this other thing happens. But we haven't explained the causation there. You know, do you get what I mean? Like just me pressing the button is not me actually explaining why the pressing of the button causes the light bulb to switch on. It seems kind of counterintuitive unless you're already a philosopher, in which case this is your kind of bread and butter. But just to the normal person, what level of description do you want to give causation? That's my core point here. Like you press the button and that switches the light bulb on, but who are you talking to? To what person is that an acceptable level of result? If I'm just speaking to just a random person off the street, that might be enough. My pressing of the button literally causes, like literally in a logical sense, this thing happening will always cause that happening. But we haven't actually proven that, right? So to a scientist, for example, my level of causation may be that the electrons in the wire are going to move and they do this, and then they go and they somehow activate the light bulb. So then a quantum physicist will look and say, oh, well, you have these kind of interactions and these waves and they're wriggling through space, and then basically that is what actually causes that. But you see the problem here, this regresses infinitely. The question of what causes what keeps going on forever. It doesn't stop. If something is literally strongly correlated enough, does that just imply causation? Before, we assumed that if we have two things that are correlated, then it doesn't necessarily mean causation. But take the switch example, okay? So we're saying that we don't actually understand the mechanism by which the switch turns on the light, but we know that we can do this experiment 1,000,000 times, and every time we do it, the light will turn on. Is that literally a causative link? And if it is a causative link, then does true correlation imply causation? Of course, we can talk about this mathematically. We can talk about like different models we can use about how we describe correlation in terms of like, okay, we use like a Pearson correlation coefficient where like we measure the spread of a bunch of points and like we kind of estimate a correlation. Fine, that's one description of correlation. But in fact, what does correlation actually mean itself? Right? Does it literally mean that when one thing happens, then the other thing happens? Because if that's the case, then that's literally the same as causation. I don't understand. That's at the fundamental level. If my doing one thing must have this other thing as the result, then they cause each other, at least in the day-to-day sense. So then correlation without it being causative is simply just weak correlation. If correlation is strong enough, then it must be causative. So that's one angle I suppose you could look at it in. Another angle is questioning what we even mean by causation. And the reason that this matters, the reason that this isn't just some kind of philosophical question, is because causation is like one of the most foundational principles of logic in mathematics that you do that literally everything else requires. So it seems to be something that needs to be important enough to have a clear definition, I suppose. So I ask again, what in the fuck is causation? Like I said, I didn't really like read some kind of book on this. I don't have all the terminology, etc., etc. I'm just thinking about this, thinking about the issues we run into here from first principles. And I'm sure someone has in the past at some point ran into the same issues, and if you know something like that, you can feel free to leave it in the comments. Okay, so there's a few ways you can conclude here. And for me, the most obvious thing is that it enlightened me, it kind of opened the switch for me that science is not a measure of objective truth. And that's not an issue, by the way. Science doesn't need to be a measure of objective truth. Science, philosophically or logically anyway, pretty subjective. And that's because the purpose of science is fundamentally a practical one. We're trying to make observations and experiments of real things in the real world that are usable and tangible. The key error that I think people make is that they try and conflate science with an actual philosophy or worldview. So for example, there's like the debate about science versus religion. This is a complete category error, but it's such a commonly held like duality, even though they're completely different categories of things. A religion or a philosophy, for example, is a literal worldview. It's a claim at objective reality, whereas science is subjective models of reality for useful purposes. So the only way you can make the conflation between the two, and even categorizing them in the same breath, is if you have a different understanding of what science is than what I've just explained. If you genuinely believe that through science you can come to some kind of objective truth about reality, that's a claim you could make, I suppose, but it's not as clear-cut as people seem to make out. In fact, it seems counterintuitive, if anything. So then there's a few questions that I'm going to leave you with as the viewer, and a few questions that this begged for me. Does objective truth even exist? If it does exist, then is it worth pursuing outside of philosophical circles? Remember, I started this video by telling you that I only am interested in things that are actually useful to me, but should I be questioning what things are worth paying attention to and studying in more depth? And where does causation fit into all of this? I don't have the answers for any of these. You can debate them or let me know your opinions on them in the comments down below. Subscribe to join a community of like-minded thinkers and see more analysis like this. Like and share this video so that the conversation can grow. Thank you for watching and have a nice day.